Okay. Hello, everyone. Hello. Welcome. All right.
I'll put us closer.
Okay. No worries. Okay. Welcome, everyone. Today, I'd like to talk with you a little bit about, just about 40 minutes or so, about Foreman and its relevance to infrastructure and virtualization. So just for me to know, how many are using or know Foreman here? Wonderful. I can go now, I think. Okay, cool. So it's new sets of slides, so hopefully it's not boring for everyone, including myself, to do a repeat. And so I'm meaning maybe I'll fail with the new slides, so bear with me. All right, so first of all, what are we talking about in terms of Foreman? I'll do a very quick introduction of what Foreman is about, so we're all on the same page. Normally, we're talking about lifecycle of servers, where they have a start somewhere when they're initially provisioned or set up, all the way to whatever needs to happen to make them production ready, up to the point where they eventually stop. It could be very short, could be very long period, depends on your use cases. We specifically talk about focusing on integration with configuration management and provisioning services, and monitoring the infrastructure where it actually is supposed to be. Is it running and configured the way it's supposed to be? So when we talk about provisioning, I think Foreman has a unique point of view in terms of allowing you to go all the way from bare metal, all the way to virtualization and cloud with pretty much the same process. So if we think about large organization, usually, sadly, there's not only a single system. There's maybe bare metal and virt, or maybe cloud or hybrid cloud, multiple data centers, multiple combination of things. And when the complexity goes higher and higher, at the end of the day, the people who actually launch those stuff could be API, but could also be operators, and we want to simplify the process for them. So it's pretty much the same process whether you deploy on bare metal or deploy in EC2 or openstack and so on. In terms of configuration, I assume most of you are well aware that today most configuration, automatic configuration is done with some sort of a framework, whether it's Puppet, Chef, Ansible, Salt, CF Engine, and Rudder, and so on. So the idea is not simply to try and bridge those gaps, between the provisioning process, the setup process, and the reporting process, all into a unified framework. And when we talk about monitoring, it's basically making sure it's not a Nagios typical type of monitoring, but actually making sure that the policy that you've set, your configuration management policy that you've set, is actually is done correctly or not correctly, and then you could get all kind of information about what's going on. Also, inventory of your systems and the ability to scan and search and get information. In a nutshell, Foreman's architecture has basically four major components. We have Foreman itself, which is a Ruby on Rails application. We have smart proxies. We have the integration with configuration management, the compute resources, and obviously the UI, API, CLI, and all of those elements. So when we talk about smart proxies, it's basically a mechanism allow Foreman to reach out. If we think about large-scale organization that probably has lots of data centers, lots of networks, lots of different network types and network segments. So a proxy is kind of a gateway that Foreman can reach out and manage remote services running on remote data centers or isolated networks. Whether it's things like maybe, I don't know, your DNS, or maybe just BMC and manage your IPMI bare metal servers. The smart proxy itself, because we are trying to kind of mix and match a lot of things, the smart proxy itself can actually run on Windows, for example. Obviously, it runs on Linux and talks to standard DNS services, but can also run on Windows if you have an enterprise and you have some Active Directory, things like that. So we try to integrate and expose a REST API across all of those services. So it's kind of one REST API, for example, to add DNS, and then many providers in the backend, whether it's Active Directory, bind, and so on. The configuration management, so we have a very deep integration at the moment with Puppet when it comes to things, and Chef now starting as well, but things like knowing what's going on, knowing which reports, what actually happened on your systems, which inventory do you have, and obviously what is the role and what the system is doing. It's not enough just to have a just enough OS, a juice. We want to know exactly what's is installed on that system and what's its purpose, maybe even more important. There's multiple environment support, staging, production, I don't know, multiple versions of production and so on. And integration with all of that, making it kind of seamless as much as possible to the user. When we talk about compute resources, this is the way Foreman basically reach out to remote systems, whether it's ovirt, openstack, VMware, EC2, libvirt directly, and so on, Google Compute and so on, rackspace, and allow, basically abstract the process of what is involved, what's required to actually make a change, and abstract it into a single process regardless of the provider. So we use a library called Fog, Ruby-based, very popular library, which we happily contribute and use. Then we have another abstraction, which we call compute profiles, which allows us to, let's say, define our own sets of defaults. For example, we could think about the traditional small, medium, large, and then define what is small, medium, and large on every different provider. And also for a different set of customers. So we can use, we don't identify, for example, OpenStack as OpenStack. Obviously, it's a tenant in OpenStack. So it's a given user in OpenStack. Same goes for EC2 and so on. And we can define different sets, different defaults for each one of them. So later on, we will be talking about a higher level object. For example, I want to deploy a small web server. And that definition of a web server or your app or whatever it is something we call host group, which is basically the system the definition of your system. So it's a way to say this is the default operating system I want for my web server. This is the default Puppet relationship or Chef recipes, and obviously associated with the compute profiles. Now, why I'm telling you that? Because the idea is that you can define a higher level object such as a web server and have the ability for Foreman to spin up a VM, create an image for it on every different provider automatically. So I have all of the information I need up front to define the system regardless of where it's going to run. I can define that a web server, I have all of the recipes, all of the ingredients to make it happen on different clouds, and then I don't need, I can easily transform and rebuild the same system on a different cloud if I would like. We could also do more interesting things. For example, detect that there's some sort of a drift. If there was a package update that we can detect from, let's say, a Puppet report and, that claims that it took maybe more than a minute, maybe it makes sense for us to spin a new VM, make a snapshot that, make an image out of that, and automatically, next time a system boots up, it will consume the latest image. So there's a lot of nice things we can do, abstract that, and I don't know if you ever use the traditional image building tools, but this approach actually uses the storage of the end provider. So I'm not building an image on my laptop and uploading it to EC2, for example. I'm actually building it in EC2 in the first place. When we talk about provisioning, we talk about basically everything we can support. So we go all the way from traditional PXE-based to image-based. We can do the traditional USB or ISO or IPXE manipulations. We can, if we're doing image, obviously use the data or SSH to reach out to the image, to the system involved. And as a complementary, when you create a new system in Foreman, it automatically creates the DNS records. If it's PXE, the DHCP reservations required for it to PXE, and TFTP, and certificate signing, and all kinds of things that are required in the process. We have also PXE-based discovery. This is more for the use cases of, I have a rack of servers, I turn them on, I want them to automatically show up and start manage them. I don't want to insert a MAC address for every new bare metal system that I got. So there's the ability just to discover all the systems. They basically launch into a minified CentOS operating system that is like a live CD, reports all the inventory, and then you can make decisions based on that. You want to automatically provision it, or select this system belongs to this organization or this tenant, and so on. We're also operating system agnostic, so we'll happily install for you any of these operating systems and others if you're willing to send the patches along the way. So as part of, I mentioned it earlier, but as part of the creation of a system, a lot of things are happening. So it's not just enough to create a VM and maybe it's storage. I also want to create the DNS. I want to sign a certificate. I want to make sure, if specifically for bare metal and virt, I want to control the IP address. So we have IP address management and that we offer automatically an unused IP address. And a lot of things that happens when you create a new system. That's completely extendable through our plugin system. There's a plugin hooks that allow you to add your own hooks. And we try to, when something fails, we actually make a lot of effort to ensure that we don't leave stuff tagging. So if I create a VM and I fail to create the storage, or if I create something else, I'm not going to leave something in the air that the IP address will be used and no one can use it anymore, for example. Now, we've been around, and we know that most of these features are mostly for enterprise users, people who have very complicated and large environments. And in that regards, we obviously integrate with either LDAP, Active Directory, Kerberos, and whatever your SSO approach, if you know how to configure remote user in Apache, for example. We have RBAC, we have detailed audit logs, and we also have multi-tenancy, multi-location, so you can go up to define the location as, I don't know, Bristol, or you can define Rec 5 in Bristol's data center, west, east, whatever, and so on. So there's a hierarchy that you can go down and define locations. So we try really to make a traditional sysadmin lives a bit easier. Obviously, when we have this kind of system, we would know which resources, or the administrator will define which resources are available, for example, for which location and organization. So we would know that this network, for example, is accessible in this building, or this network, or something in your infrastructure is mapped basically to a given context. So the QA team may be allocated to different resources than the engineering team in location A or B, and so on. Now, Foreman is really, really pluggable. There are a lot of plugins. This is really just a tiny list of plugins. Plugins could be as simple as sending a U-boot notification, or as complete or feature full of features like as Catello for content management. There's really a lot of, everyone can extend it. This is traditional if you're Ruby on Rails developers. This is just a Rails engine with some API around it, so it's really easy to extend and add as required. Obviously, it comes with a REST API. We have multiple versions of API that we know that API is one of the most important things we try never to break. So we went through the exercise of adding multiple versions, and out of the API, there is really, I think one of the things that's really useful is the powerful search API. That means we have a really rich search language, which allows you to figure out and find the exact resources that you're actually looking for, regardless of in a specific context. So you could easily automate over the API with a specific search query, and you can fully automate it. A very natural example is I want to monitor something. What do I need to monitor? So you can simply define a search query. I want to monitor all of my web servers in location Bristol. So you define it as a search query. You feed that back into your configuration management, and your configuration management systems can simply manage or start monitoring it automatically. You don't need to start writing all your customized scripts that whenever a new system comes up, I need to add it to my monitoring and all kind of things like that. I'll try to show, if there's enough time, I'll try to show some demo around that. We also have a full-featured CLI called Hammer. Similar, we took the approach of Git sub modules. So it's a Hammer and similar commands. It uses the v2 API, and it's actually built from day one to support Foreman plugins. That means that if you write your own plugin to Foreman, you can actually extend the CLI with a plugin that automatically, dynamically learn from the API the various options that you can consume. Now, I wanted to put some niche, try to put a bit of a real use case that we actually use Foreman that may be a bit more relevant for this room. And I think deploying OpenStack is something that's a pretty large topic. It's been discussed heavily. And as you saw earlier, there's O, there's quite a lot of different tools. Every configuration management tool has its own set of recipes to deploy it. And we try to make this problem a bit smaller, if possible, and using a customized Foreman plugin. So I'm just going to show you a few screenshots. So this is based on RDO. For those of you who don't know, RDO is a distribution of OpenStack for CentOS and Rails-based operating systems, which is pretty easy to install in terms of it's all packaged and all of that. And RDO and Foreman actually comes together, bundled together. So if you're using RDO, you can actually install Foreman. They're configured when you configure the RDO repositories. In this case, it's just yum install and the Foreman OpenStack installer. And basically, we get back to Foreman with a set of screens that allow us to create a given OpenStack cluster. So obviously, you can create multiple clusters of OpenStack. Staging, testing, small, mini, latest, whatever. And you can just define, tries to guide you through for the various, what is a bit about the networking, a bit about various parameters I don't know if you have HA or floating IPs, and allow you to override any different values. It also automatically generates passwords, and we try. It's not perfect, but we try to simplify the process of deploying OpenStack, so someone without a lot of knowledge can actually even deploy OpenStack in a relatively straightforward manner. 2 to 3 screens, click next, and go and create OpenStack. There's a lot of options for OpenStack, and I think the diversity here is what makes it so challenging, because there's a lot of overlapping combinations in OpenStack, and this is a real problem for configuration management in general. And we're working hard now on coming up with a new approach in the configuration management area to try and solve that. But I guess this is another topic for another room. Generally about Foreman's community. The project is about 4-year-old, roughly 250 plus users on the the IRC, and some figures here you can see. We're growing as much as we can. These are roughly the numbers. Most of our users, or I would assume all of our users, are enterprise users or users with infrastructure. Otherwise, it doesn't make sense to use this kind of a product. And I hope I've convinced you a bit to get started. I'll try to do a demo, but in between we'll pause for a second for questions. I mean, to get started, you can obviously see it on the website. If you go, there's some tutorial videos how to get started. We have a really active IRC channel and a decent user group. So if you have any questions before I try to do a live demo, go ahead. Now's the time. Yep. How do you deploy Windows? That was the question. Can I ask you a question back? Why? No, kidding. All right, Windows deployment at the moment is possible for image-based provisioning only. So if you have a template in ovirt or an image in OpenStack and so on, it's possible just like any other, if it's user data driven or SSH, we can hook into that. Okay? Yep.
Your provisioning method sounds a lot like what Razor does. Do you guys integrate with Razor?
We don't integrate with Razor directly. There is some overlap. So I'll try to give background to your question, right? Because I'm not sure if everyone understands. Razor is a great provisioning tool started by Puppet Labs. Maybe they're here. Which has started from day one with the discovery principles in mind. That means you turn on servers and they can automatically assign themselves roles, functionality based on predefined roles. Foreman existed before, and we added the discovery functionality similar to Razor somewhere around after Razor started. We did consider using Razor as a compute provider in Foreman, but that never happened from one reason or another. It's not a, we had a lot of that logic already. It didn't necessarily feel right to rewrite that or drop all those stable lines of code for alpha at that point in time, a beta or an alpha product. I think today Razor is a great product, and if it solves the problem that you're facing, it's great, and you should use it. I think we're trying to aim. The overall use case is Razor is a service in that regard, that it can create bare metal systems, that you can consume bare metal systems. In this case, we're trying to add a few more dimensions to the management of the whole problem, let's say. Okay? Right. More questions, if there are any. Yeah?
The future of Foreman?
I didn't.
Where do you see the future of Foreman? Where do you see the future of Foreman?
Where do I see the future of Foreman? So there's a short-term future and a long-term future. Short-term, one of the completely new two main functionalities we're adding into Foreman, besides enhancing the current things we have, is first of all everything around content management. That means the ability to classify your content and manage its life cycle. So what is production? Which packages are production? What do they mean? How do we do testing and staging? And how do we promote content from one point in time or one set of functionality to another? So when I deploy a system, I'm not just randomly getting a set of RPMs, for example, or repository and configuration data from a certain point in time where I installed it, but actually as a way that you can say, this is production, I can deploy my production, or this production, I can take the production that was 5 years ago and deploy it now again. So really try to look at the whole content problem as something which is kind of a snapshot of content that is consumable as you go forward. This is important if you have to have multiple versions of your production. Maybe you have two sites and one site can perform a change at a given time, the other site can perform a change at another time. How do you orchestrate all of that? That's one thing. The other thing we're working on extending the remote execution framework, and this is more for complicated workflows. So if you need to dynamically orchestrate change across multiple systems, I'll take an example from ovirt, for example. When you want to upgrade a hypervisor, what do you need to do? You basically need to go to each hypervisor, put it in maintenance mode, so all of the VMs running on it will live migrate to another VM. Then you want to upgrade its packages. Maybe if a kernel was upgraded, you want to reboot the system. Then you want to go to the next one, take it out of maintenance to go to the next one, and do this cycle again. This is just one example of an orchestration framework that as a problem that we're trying to solve. So we want to build a framework that is easy to use, that can automate this kind of workflows. And there's probably a lot of things that happen, as an open source project. We're amazingly surprised with the pull requests that we get. So besides that, I have no, where we'll be in 2 years, we'll see. All right. More questions? Only this guys were asking. Okay. All right. So I'll try to, given we have enough time, right? David, there's enough time? Enough time? Okay, cool. So I'll try to jump and do a demo, if the gods of wireless will allow me. Let's see. All right. So this is Foreman's dashboard. In here we can see a bit of kind of a pie chart of showing us in which state our systems are. So I could see that 40% of my systems are in OK state. That means that they've run a configuration agent on them, let's say Puppet. Puppet executed, and there were no changes. That means the policy that we've predefined is applied. Everything is working great. Move on. The out of sync basically means nothing happened. So the agent did not run, and we don't know whether what is the actual state of the system at the moment. And no report. No report means you never send the report. Not so interesting. There's also other states. This is a live system or my lab setup, so there are more errors, but obviously if something failed to execute or things like that, we could see. We have, let's see. We have obviously, this is too slow over there. I'll try to see if I have a local copy of the database, maybe. No. Okay, we'll go back to VPN, but this takes a while. So while you look at that, I just saw, no, never mind. So basically, this is too slow. I would encourage in the meanwhile, all of you to come. We have a booth outside at the K building, and also if you're happen to be in Ghent on Monday and Tuesday, there's a configuration management camp, so you can ask more questions. There's also a couple of more talks about our continuous integration infrastructure and integration with Chef happening today and tomorrow. And unless no, this is too slow. I'm sorry. Besides that, I think I covered the basics. There's more questions to save me, so go ahead. The question was, what is the relation between Foreman and heat? Or is there a relationship between Foreman and heat? At the moment, there is no integration between Foreman and heat. I would love to see one. I would love to see heat be able to consume resources from Foreman. I would love to see Foreman manage heat templates. I think these are two things we would love to see. And yeah, this is sadly the resolution a bit too small. But generally, this is at the moment there's no such template. Yes. Question in the back? Yeah. Okay. So the question was if there's a plan to fix host groups, right? Okay. So this is only for those of you actually using it can know the problem. So host groups have a nature of being able to inherit. So you could define a top level base or my app, and out of that you could say my database and my web server or my whatever functionality, and you could go nest pretty much unlimited level of down in the tree. And you can share parameters between those, and you can share those benefits. You could define things that are commons and share information between those using search or other mechanism. And one of the things, and correct me if I'm wrong if I translated it incorrectly, but what you mean is basically the ability not to redefine Puppet classes, or what is the exact problem in this? Can you Okay, so at the moment in Foreman it's possible to, so we started with the term host group, and later on it actually grew to something we now look as a system definition. And if we look at it from as a system definition point of view, it doesn't make sense for a system to have multiple definitions. But to solve that specific problem, we'll be working probably in the near future to handle classes and classes groups that can be reassigned. So take what you look maybe as host group and try to extract it to another object that could be applied in multiple. Then you could apply multiple, let's say, Puppet groups or Puppet classes, recipes, whatever it will be called, and you could try to solve it in that approach. But there'll still be only one host group per system. Yes, but we'll try to handle that specific use case, which I think is what you're referring. We can take it offline, and maybe you can enlighten me why we're doing it wrong. I'll be more than happy to learn how to do it right. Right. Anything else? Okay. Let me quickly try. I'll open some tabs so they're a bit not as slow. So when we talk about and last. Okay, I've opened a few slides. Let's see if. Okay. All right. This concludes the live demo. We're more than happy to show it later on. We'll make sure that we have a working live demo later on down the road, so you feel free to play. Thanks, everyone.
γιατί και μου δίνει λίγο στα νεύρα σε σημείο που να το φτάσω στο... Εκεί είναι, αλλά θα σου πάρει 2 χρόνια γιατί δεν τα λεφτά για να βρεις όλοι.
Ελάτε να το πιάσετε, να το καταδικάσετε.
Ποιον? Τώρα ναι, τώρα μου είναι στα νεύρα. Όχι, δεν είναι.
Project. Yeah.
Okay, is it on? So, hello everyone. Hello? This. And now it's on, right?
Speak a little.
Hi. Finally.